Our next speaker is Noel Gurwick. He describes himself as an ecosystem scientist with strong engagement at the science policy interface. Noel was a AAAS Science and Technology Diplomacy Fellow from 2008 to 2009, placed at the State Department. Tonight, he will present a project he has been working on with Tom Rockwell, Director of Exhibits and Associate Director for Programs at the Exploratorium Museum in San Francisco. Here's Noel Gurwick discussing the size of things.
Thank you. Thank you all for coming. The computer scientist Daniel Hissel proposed to build a clock as big as Stonehenge. It would gong every 100 years. It would run for 10,000 years. It would be an icon. It would, in his mind, change the public discourse, the way we think of ourselves in time. Charles and Ray Eames were concerned with space, where Hissel was concerned with time. Their film, The Powers of 10, starts looking at a couple on a lakeside, zooms out and out to the universe, in and in, through skin, through cells, through molecules. In this drawing, our aim is to engage your imaginations and to present an understanding of how humanity fits in this broad context that is based on science-related observations. From the center of the spiral, look to the left, where the eye stares out at you from this tile at the scale of 1 centimeter, 10 to the minus 2 meters. You can't see everything in all of these tiles in 20 seconds. I encourage you not to try. You can look where you're interested. You can follow my narration. To the right of the eye, a fingertip. On top of the fingertip, a grain of rice. To the left of that, a Pentium chip. The top tile repeats in the next slide. From where we had the fingertip, now we have a hand holding a pen, writing, language. To the left of that, a finch, maple leaves, and on the tile on top of that, the leaves give way to a grove of bamboo. Next to that, a thatch hut. The thatch hut, in that tile, we also see a farmer, not of the modern day, but from early agricultural times, where we had the fingertip and the grain of rice. Now at the 1 meter scale, we have a farmer with a hoe. And on top of that, in the next tile up at the 1 meter scale, the thatch hut gives way to a house. The bamboo grove gives way to pine and maple trees. And at that same scale, the Hubble telescope and the Wright Flyer. At the scale of 100 meters and 1,000 meters, what do we see? We see at the 100 meter scale a steamship and redwood trees. At the 1,000 meter scale, the steamship from the 1830s gives way to an oil tanker. Above it, we see the northwest corner of Central Park. We see a nuclear waste site. We see an Indus city from 2500 BC. We're at 2500 BC, the Indus city from 10 to the 3rd meters. At 10 to the 4th meters, we see Manhattan Island, the same scale as the Marianas Trench, the same scale as the nucleus of Halley's Comet. And to the right of that, what do you see? What do you see at 10 to the 5th meters? At 10 to the 6th meters, we start to see the scale of Amazonian deforestation. We see the distance from New York City to Chicago in the middle of that upper tile, 1,000 kilometers. And by the 10 to the 8th meters, we see the larger planets in the solar system. We've gone 10 orders of magnitude from 10 to the minus 2 to 10 to the 8th meters, about 1/2 turn around our spiral. We're going to jump 1/2 turn more to 10 to the 20th meters. So the fingertip and the grain of rice are to the largest planets of the solar system, as the largest planets in the solar system are to what? Are to what? 10 to the 20th meters, a view of the Milky Way galaxy from the center on its side. An order of magnitude bigger than that, the Andromeda galaxy. What's the biggest we could get? What's the biggest we could find, the biggest object we could find? What objects would you place in this poster? The biggest we could find was at 10 to the 26th meters, the observable limits of the universe in about 1996. It's not a static number. The observable limits of the universe get larger because there's more time for light to come to the Earth, so the amount of space we can see gets bigger. We're going to jump back to our 10 to the minus 2 meter scale, and we're going to go now counterclockwise around. (10 to the minus 2, 10 to the minus 3, 1 millimeter scale. a flea, a telephone wire diameter. A millimeter and down, in the very center of this slide, a human egg at 10 to the minus 4th meters. On the left side, we go from sand particles to silt particles. Another slide or two down, we'll see clay particles. Why did we include sand and silt and clay particles in the size of things? The mix of sand and silt and clay has tremendous influence on the earth. It determines how water flows over the surface. It determines soil fertility for agriculture. A transistor at 10 to the minus 5th meters near the outside edge, an early transistor. Transistors keep getting smaller. At 10 to the minus 7th meters now, at the bottom of this slide, there's another transistor, 2 orders of magnitude smaller than it was in the previous slide. Coming out of the center of this spiraling out at you, an asbestos fibril at 10 to the minus 8th meters, and cutting across it from left to right, a DNA double helix. The DNA double helix appears again in that next frame. And between about 10 to the minus 11th and 10 to the minus 13th meters, there really isn't much to see. There's not much there between a hydrogen atom and a gold nucleus. It's just empty. Think about how that compares to how dense, how many choices we had to make in putting together the tiles at the 10 to the 1st, the 10 to the minus 2nd, the 10 to the 4th meters. I've been showing you 2 to 3 tiles at a time. Our intention was to show you the size of things at a glance. The next few slides show more tiles at once, and I invite you just to look at them and let your imaginations wander where they will. Many of us are familiar that science in the modern age can be a very narrow discipline. Part of our intention, part of our contention in this illustration is that science can also be a very integrative force, and it can be very helpful to us in understanding where humanity fits in the world. Thank you for your attention.